Hello friends, welcome to my YouTube channel. Friends, today we are going to discuss the maximum fluctuation of energy and determination of the maximum fluctuation of energy from the turning movement diagram. Turning movement diagram of a multi-cylinder engine is shown on this page. Now friends, here AH represents the mean torque line. This AH is the mean torque line. Okay friends, and A1 is the A1, A3, A1, A3, A5, A7 are area below mean line shown by negative loop. These are negative loop. And A2, A4, A6 are area below mean or above mean line shown by positive loop. These are all positive loops. Okay friends, these three are positive loops. These areas represent certain amount of energy which is being added or subtracted from the energy of the moving part of the engine. Okay friends, now friends, let us assume that energy at A, this point is E, that is energy at A is equal to E, and energy at B, we have to find out the energy at B. The energy at B will be equal to energy at A minus A1. Why? Because this area is lying below the mean torque line, so this loop is negative, so I will subtract the value of A1 from E. And energy at C, we have to find out the energy at C. Energy at C will be equal to energy at A, which is E, minus A1 minus A1 plus A2 plus A2. Why? Because A1 is negative and A2 is positive. That's why I have subtracted A1 from E and added A2 to E. Now energy at D. Now energy at D will be equal to energy at A, which is equal to E minus A1 plus A2 minus A3. Okay friends, energy at E will be equal to energy at A, which is equal to E minus A1, which is the negative loop, plus A2, which is the positive loop, minus A3, which is the negative loop, plus A4, which is the positive loop. And energy at F is equal to energy at A, which is equal to E minus A1, which is negative loop, plus A2, which is positive loop, minus A3, which is a negative loop, plus A4, which is a positive loop, and minus A5, which is a negative loop. Okay friends, so this is the case we have in this case we have find out up to F. Now similarly we can find out energy at G and H. So the energy at G, we have to find out the energy at G now. So the energy at G will be equal to how much? Energy at G is equal to energy at A, which is E, minus A1, that is the negative loop, plus A2, which is the positive loop, minus A3, which is the negative loop, and plus A4, which is the positive loop, minus A5, which is the negative loop, plus A6, which is the positive loop. So energy at G we have determined. Similarly, we can find out energy at H also. Energy at H also we can find out. So we have clearly find out energy at all the point at which this torque line is intersecting the mean torque line. That is, this torque diagram is intersecting the mean torque line AH. Now friends, we can see that the energy at point denoted by the E is maximum and the energy at point B is minimum. Why? Because suppose we can say that we can assume that let the area A1 is how much? 1 unit. Area A2 is how much? 2 unit. Area A3 is equal to how much? 1 unit. Area A4 is equal to 3 unit. We have to assume the value of the, I am assuming just to show you how I am finding the maximum energy and minimum energy in the cycle. And area A5 is equal to how much? 1 unit. And area A6 is 1 by 2 unit. And area A7 is equal to how much? 2.5 units. Now when we substitute the value of the area here in EB, EC, EG, here ED and all these energies, then we can find out the energy of the point. Now friends, we can see that when we substitute the value of these areas A1, A2, A3, A4, A5, A6 and A7 into these energy, we can find that energy at E, which will come out to be very high, and the energy at V will come out to be lowest. Energy at B will come out to be very lowest and energy at E will come out to be maximum. So the maximum energy is at B, this point, and the energy at E is, sorry, the minimum energy is at B and maximum energy will be at E. So we have found out these 2 points, that is where the energy is minimum and the point where the energy is maximum. So the maximum fluctuation of energy denoted by delta E will be given as maximum energy in the cycle minus minimum energy in the cycle. So the maximum energy in the cycle is at B and maximum at E, and the minimum energy in the cycle will be at B. So friends, this is the method by which we can determine the maximum fluctuation of energy in a cycle, and the coefficient of fluctuation of energy denoted by CE is given as maximum fluctuation of energy divided by the total work done in the cycle. Okay, this is work done in the cycle. So work done in the cycle can be computed using T mean into theta cycle, that is the area under this curve is the work done in the cycle, which can be given by T mean product into theta cycle, that is 360 degrees, which will be equal to 2 pi, that is this T mean into 2 pi here. So the theta cycle varies with respect to the engine. For example, for 4-stroke engine, theta cycle is given as 4 pi, and for 2-stroke engine it is given as 2 pi. This is for 4-stroke engine and this is for 2-stroke engine. So this was all for today's topic, friend, and if you like my video, you can subscribe to my channel and also press the bell icon for the notification of upcoming videos. So thank you, friends.